All right, welcome to today's video. In today's video, we're going to review arrays, what a product is, what a factor is, what a factor pair is, and how those things can help us find what a prime or and composite number is. So hang tight, we're going to go through this fast. If you need to, watch this video as many times as you want. All right, so here I have some shapes and some squares and stuff like that. And these things, if you remember right, are called arrays. Arrays are just a way of showing us multiplication projects. It's columns and rows, and they all have to be equal. So you can't have one column that sticks out like this, remember. So that is not an array if you have a column that sticks out like that. They're all equal in the columns, and in the rows. They're all equal. So all the rows equal each other and all the columns equal each other. So next, we need to find my dimensions of my arrays again. What are my dimensions? Yes, a dimension is just the length or how many boxes go along the side. So my dimension for this one is a 1, because it's only 1 across. My dimension for this one is 1, 2. Horizontally, for my row, it's 1, 2, 3, 4, 5, 6. Am I done with my dimensions? No, we need to get the up and down dimensions. This one, if you want, you can count them all, but it's 18. I'll help you out. This one is 1, 2, 3, 4, 5, 6, 7, 8, 9. This dimension is 1, 2, 3. A 3. All right, so now we've written some stuff and we filled in our arrays and we found the dimensions. Can you tell me where I would find a factor? A factor, remember, is just one of the numbers you would multiply to get a product, not both. So 1 is a factor, 6 is a factor, 9, 2, 3, 18 are all factors of 18. Where would I find my factor pairs? Some of you might have done this was factor. Where are my factor pairs? Yes, my factor pairs are linked on the same array. So my factor pairs are 18 and 1, or 1 and 18, 3 and 6, or 6 and 3, and 2 and 9, or 9 and 2. Those are my factor pairs. So, as you can see, 18 has more than one factor pair. This helps us determine if a number is prime or composite. If a number has more than one factor pair, because these are together, they can be flipped, but they're still together, it is a composite number. And that's more than one factor pair. (18) is composite. Let's erase this real quick and talk about what a prime number might be. So a prime number has only one factor pair. What would that look like? So I just happen to know off the top of my head, 7 is a prime number. So if we were to try to draw an array with 7 in it, you can only get 1. Remember, an array cannot look like this. You can't have 3 in one row and 4 in another. It is not a square or rectangle. That is not an array. So this is not an answer you can do when you're trying to find a factor pair. So if I'm trying to draw it out, I can only draw it one way. I can only draw it or I can only find one factor pair of 1 and a 7. So a factor is always going to be, a prime number, sorry, is always going to be just 1 times itself. No other factor pairs will make it. You can't do 2 times a whole number will not get you a 7. 3 times a whole number will not get you a 7. Only 1 times 7 can get you 7 as a product. So remember, a composite number has many different arrays that you can make with different dimensions. Like 12 has 1 and 12, 2 and 6, 3 and 4. That's a composite number. 5 only has one multiplication problem that you can get to get 5, and that's 5 times 1 or 1 times 5. Those are the same factor pairs, remember, because you can flip them back and forth. That's what makes that a prime number. So we are going to go over these a little bit in class of what a prime and composite number is again. If you have any questions, please ask. Otherwise, I'll see you in the next video.